So today we are going to cover only one lesson in the book, but that one lesson has two topics. 8.1 covers the square root property and completing the square. So we'll cover the square root property first, and then completing the square. Completing the square is a pretty tricky concept, which is why we're only doing one lesson today. But I'm confident that if you go through this lecture and you can pause it and take your time, that you should be able to pick up on this concept pretty readily. So let's go ahead and start with the square root property. The square root property, as found on page 679 in your book, says that for any non-negative real number c, if x squared is equal to c, then x is equal to plus or minus the square root of c. So this first part right here is just the disclaimer we've already discussed. The number inside the radical is going to be a non-negative real number so that this all works out. So what we're going to have is a variable or an expression squared equal to a number, some non-negative real number, and once you have that set up, then you can take the square root of both sides. So let's start with a really simple example, which will be question 1 from MyOpenMath. Okay, so here we have question 1 from the MyOpenMath homework. Here we have a variable squared. You need to get this variable squared all by itself before you get started. Once it's all by itself, set equal to a non-negative number, then you can take the square root of both sides, and this is the work you will show. Square root on the left, square root on the right, and at this point, it is imperative that you also write the plus or minus sign. So the plus or minus sign needs to go on one of the two sides. Traditionally, it's put on the side with the number, not the variable. From here, we then go to the next line. Of course, the square root of y squared is just y. The square root of 48 can be simplified by splitting 48 into 16 times 3. The square root of 16 is, of course, 4. And we're done. It's a very common mistake for students to forget this plus or minus sign. Sometimes students forget it altogether, and when they give a final answer, they only give the positive version. They only provide one of the two solutions, which is of course incomplete. You need to provide both solutions. You can write the solutions just like this, or you could write them in a solution set, such as this. Here's the first solution. Here's the second solution. Now we've listed them in set notation. The other common mistake that students make is that they forget to put the plus or minus up at this step. Sometimes students will do the square root on both sides, but forget the plus or minus here, and then the plus or minus just appears somewhere in their work. That's not as bad of a mistake, but you do need to include the plus or minus from the very beginning. The point at which you put the square roots down is the exact same line of work where you must include the plus or minus symbol. Okay, now let's go on to some harder examples. My next example is from page 688 of the textbook, number 22. The first step is to get the perfect square all by itself. Get the variable by itself. So here, x squared is the perfect square. Okay, that is the perfect square. We want to get that all by itself before we apply the square root property. So what that means is that we first add 49 to both sides. You don't have to show plus 49 plus 49. Okay, so at this point, we still have not isolated the perfect square because 5 is not a perfect square. So before we apply the square root property, we must divide both sides by 5. These two parts of work, the plus 49 plus 49 divided by 5 divided by 5, are not required. What I've written in black is required. Now at this point, the perfect square is isolated. Let me write that 2 a little bigger. Okay, now we have the perfect square all by itself, the variable squared all by itself, and now we're going to take the square root of both sides. So make sure you show this part. Make sure you show the square root being applied to both sides. And when you take the square root of a fraction, make sure the square root symbol goes low enough that it's clear that the denominator is included inside of the fraction. At this point also, remember we must include the plus or minus symbol. Then in our next line of work, the square root of 49 is 7. The square root of 5 does not simplify. Okay, so this is where we must apply our understanding from earlier, that is how to rationalize a denominator. This denominator is an irrational number, so we must multiply the top and the bottom, the numerator and the denominator of the fraction, by the square root of 5. And then finally we'll get to our final answer. Since we have a video lecture, you can approach the lectures a little differently. I encourage you to pause the video often and try to do the problem on your own. And you may want to even consider, after I've done an example problem, rewind the video, go back. Rewind is from the VHS days. Okay, so go back in the video to the beginning of the problem and see if you can now complete it on your own, now that you've seen me do it. And then you can watch the video again and see if you did it correctly. That would be a great way to make use of the fact that these lectures are now on video, where you can pause and re-watch before you continue on to the next problem. You can make sure that you have a firm understanding of the previous problem. That would be a great strategy, as opposed to watching the entire lecture from start to finish without pausing it or practicing. So I highly encourage you to make use of the fact that this new medium of lecture has opportunities for you to have additional learning and additional guidance built in. This is a transition for all of us, but for you this is a real blessing to be able to pause the video, to re-watch the problems, to try the problems on your own, even before moving on to the next part of the lecture. The next problem is question 3 from the MyOpenMath. Here you'll notice that instead of a variable squared, we have an entire expression, n minus 10. n minus 10 squared, quantity squared, is a perfect square, and it's already isolated. It's already by itself. So we actually apply the square root property here in this first step. Then the next line would be n minus 10 is equal to plus or minus the square root of 21. Remember that the square root cancels the square because they're inverse functions, leaving us simply with n minus 10. Now we have to add 10 to both sides. When you add 10 to the left, of course the 10 goes away. On the right-hand side, when you add 10, you are left with two terms that cannot be combined. So this is actually your final answer. You stop right here. The next problem is question number 4 from the MyOpenMath homework. The perfect square, the square is this one right here. The perfect square is not already by itself. So first, add 49 to both sides. Now the perfect square is isolated. Now we can apply the square root property to both sides. The square root of the square, remember the square root and the square cancel. And then we'll add 7 to both sides. Plus or minus 7 plus 7 is not equal to plus or minus 14. Let's think about this. A positive 7 plus 7 is 14. But a negative 7 plus 7 is 0. So what we end up with is plus 7 equals 14, minus 7 plus 7 equal to 0. Now 2b is equal to 14 or 0. Alternatively, you could write that as two separate equations. So for instance, then you divide both sides by 2. Now, when you get to the end, you should always plug back your answers into the original equation. You can do this with a calculator, or in this case, this is pretty straightforward to do even in your head. Let's try it. Let's plug in 7. 2 times 7 is 14. 14 minus 7 is 7. 7 squared is 49. Minus 49 is 0. That works. Now let's plug in 0. 2 times 0 is 0. 0 minus 7 is negative 7. Negative 7 squared is positive 49. 49 minus 49 is 0. So then it works. Okay, question 6 from MyOpenMath. First, find the perfect square. You don't need to box it. I'm just doing this for the sake of the lecture, but there's the perfect square. Always identify it visually before you get started so that you know what it is you want to isolate. Okay, to isolate that expression, we need to subtract 7 from both sides and then divide both sides by 5. Now that the perfect square is isolated, I can apply the square root property. Now when I add 4, remember I don't end up with plus or minus 10. Take each number and add it one at a time. Positive 6 plus 4 is 10. Negative 6 plus 4 is negative 2. Then divide by 6. Then reduce. And for our final answer, I have a negative 1/3 and a positive 5/3. You can just write your answer in a set like this if you'd like, or you could write x equals negative 1/3 or x equals 5/3. Those are your options. Okay, now for the next part of the lecture, I want to teach you completing the square. Completing the square is a little tricky, but you can do it. So first, hold on, the doorbell just rang. I'll be right back. Okay, sorry for that interruption. Here on the left-hand side, we have x squared plus 2x plus 1. Now in the past, when you had a quadratic equation, I told you that you should get everything on one side and factor it. But if you were to do that, don't try this, just watch. You'd end up with a quadratic that cannot be factored. There are not two factors of 9 that differ by 2. Okay, so x squared plus 2x minus 9 equals 0 does not factor. So an alternative way of solving this equation, since we cannot factor it, is to take the fact that the left-hand side here is already a perfect square. X squared plus 2x plus 1 does factor. It factors into x plus 1 quantity squared is equal to 10. See, isn't that perfect? Now we can actually solve this equation. We can take the square root of both sides. So once you get a perfect square, you can, of course, use the square root property. So here we go. Okay, so in this line, I applied the square root property to both sides. And then from here to here, the square root of x plus 1 quantity squared is simply x plus 1. And then I have the plus or minus square root of 10. And then right here, I subtracted 1 from both sides. So this is my final answer. X is equal to negative 1 plus or minus the square root of 10. Now you may say, that's nice, but how often am I going to have a perfect square on the left-hand side of the equation, or the right? How often will I have a perfect square sitting there for me to factor? This seems like a very odd event, right? Like a unique event, a hard thing to find. And that's true. It's a very rare event that you'd have a perfect square already set up for you. And that's why the concept of completing the square is around. It is so that you can actually force the existence of a perfect square. So that's the process I'm about to teach you, how to force the existence of a perfect square so that you can factor into a perfect square, so that you can use the square root property. Okay, so let me show you an example. Okay, let's look at this example from the book, page 688, number 48. X squared minus 6x plus 4 is equal to 0. I feel like this is a fuzzy camera, so I'm trying to adjust it here. Okay, okay, hopefully that's clear. Okay, so is this a perfect square? No, it's not. How do we make it a perfect square? there's actually a formula. So what you do is first you identify A, B, and C. Okay, so what you're going to do is you're going to take C and move it to the opposite side. And when you do that, of course, the positive 4 then becomes a negative 4. And the other thing that happens is we want to leave a blank space here because we're actually going to add something to both sides here. So what is it that we need to add right here in order to make this side of the equation a perfect square? And the answer is always the same. It's use the formula b over 2 squared. Okay, so what is b? B is negative 6. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. Now, is it okay for me to just add 9 to the left-hand side? Of course not. I can't add to one side of the equation without also adding to the other side of the equation. I have to add to both sides. So let me add to the right-hand side. So what I've done to one side, I've also done to the other side, so then it's completely legal. Now I factor. And when you factor, it will always factor the same way. X, or whatever your variable is, in this case we do have X, but you could have Y or T or W. X plus B squared. The left-hand side will always factor into X plus B over 2. My bad. Let me try that again. B over 2. The same number that we had up here. Do you remember what b over 2 was? b over 2 is negative 3. So what we're going to do is factor this expression into x plus negative 3. X plus negative 3. X plus negative 3 is the same thing as x minus 3. So if this number right here is negative, then this number right here will also be negative. If this number here is positive, then this will be positive. So the signs of b and right here in the middle of the perfect square, these will match. On the right-hand side, negative 4 plus 9 is 5. Now we take the square root of both sides. And the result, x minus 3 is equal to plus or minus the square root of 5. That's the use of the square root property. Then we add 3 to both sides. X is equal to positive 3 plus or minus the square root of 5. Next, I'm going to do number 52. Number 52 from page 688. T squared plus 22t plus 93 is equal to 0. Okay, so remember the first step was to identify A, B, and C. So A is 1, B is 22, C is 93. Next, you want to move the C value to the other side. Okay, Next, what do? Next, we add b over 2 squared to both sides. What is b? B is 22. What is 22 divided by 2? 11. What is 11 squared? 121. Now remember, you do not have to think about how to factor this. It will always factor into x plus b over 2 squared. Of course, in this case, instead of x, we have t. B over 2, we already found was 11. So there's the factorization. You don't have to think about it, just use this formula. Negative 93 plus 121 is 28. Now take the square root of both sides. So by now it's very possible that you've figured out how to simplify the square root of 28 in your head. If you can do that in your head, just go straight to 2 root 7. You're welcome to do so. If you still need to show the work of splitting up 28 into 4 times 7, that's fine. So 28 is 4 times 7, the square root of 4 is 2, and then here's the leftover 7. So then we need to subtract 11 from both sides. Okay, and so there you go. That's the solution. One more problem from the book, and then I want to work through some of the examples from the MyOpenMath homework. Now, when I said you need to first identify A, B, and C, you may have been wondering why it's important to identify A. So far, the 2 examples I've shown you have had an A value of 1. So those are actually a pretty straightforward type of problem to do, but it gets a little trickier when A is not 1. When A is not 1, you need to force A to become 1 by dividing both sides by A. So identify here. A is 6, B is negative 12, and C is 1. We do not want to do this type of problem when A is not 1. So a prerequisite condition for completing the square is that A must be 1 before the use of completing the square, okay? A must equal 1 before the use of completing the square. So how do you get A to equal 1? Divide both sides by 6. So we're going to have a new starting problem. The new starting problem, when you divide both sides by 6, you end up with x squared minus 2x. I'm going to go ahead and move this over. This will become a plus 1 over 6, and I'm going to go ahead and move it over to the right-hand side. So I combined 2 steps there into 1 for the sake of space. But what I have done here is I've divided each and every term individually by 6. So when I divide the first term by 6, I have x squared. When I divide the second term by 6, I have a negative 2x. When you divide the third term by 6, you end up with a plus 1 over 6, which if you move to the right-hand side becomes a negative 1 over 6. So now this is our new problem, and this is the problem that you actually want to use. So when identifying B, don't look at the original problem. The original problem is gone. We are using the new version of the problem in which A is equal to 1, because A must equal 1 before the use of completing the square. So now we have A equal to 1. So now I can consider that B is equal to negative 2. So B over 2 squared, negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. On the left-hand side, I wrote positive 1. On the right-hand side, I wrote plus 6 over 6. 6 over 6 is, of course, positive 1, but I wrote it in this form because in order to add together fractions, you need to have a common denominator. So one thing you may notice is that so far the b values that we've had to work with are even. I chose those on purpose so that they would not be overwhelmingly stressful. If you come across a b value that is not even, your b over 2 value will be a fraction. Do not be scared by that. The fraction is at worst going to just have a 2 for the denominator. That's not that big of a deal. So it is possible that you could end up with a b value that's odd. It will mean that you'll have fractions here, but if you end up in that situation, remember you factor it in the exact same way and just follow this procedure, and whether you have b is equal to even or odd numbers, you will end up with the same procedure. Okay, so let's continue. Factor into x plus b over 2. Remember that b over 2 was negative 2 over 2, or negative 1. X plus negative 1 is x minus 1. And on the right-hand side, negative 1 over 6 plus 6 over 6 is 5 over 6. So now I need to take the square root of both sides. Okay, now, this square root of 5 over the square root of 6 has an irrational denominator. So I need to rationalize this denominator. And then for the last part of this problem, I need to add 1 to both sides. Adding 1 on the left can be like this. Adding 1 on the right can be adding 6 over 6. Your final answer will look like this. So I combine the two numerators, plus or minus square root of 30, plus 6 into 6 plus or minus root 30, all over 6, and so this is my final answer. I chose to write the 6 first because this resembles the format of the quadratic formula, which we'll be studying in the next lecture. You do not have to write it this way. Addition is commutative, so if you want to write it the other way, that's fine. So next I want to do some examples from my open math. Okay, here we have a word problem, question number 7 from my open math. We have an object that has been dropped from a height of 210 feet. The height of the object after t seconds is given to us by the formula provided in the problem. This is a two-part question. The first question is going to be the height after a certain amount of time, in this case after 1 second. And then we have a second question, when does the object hit the ground? So what is the height after 1 second? The height is unknown. What is known is the time. So we replace time with 1. So every occurrence of t is replaced with 1. And this is what the work looks like. Okay, so 1 squared is 1, 16 times 1 is 16, 210 minus 16 is 194. You can, of course, use a calculator. So 194. But remember, this is a word problem, so we do need to include the units. Here we would say feet. the problem tells you on MyOpenMath that this is a feet problem. Okay, so then the second question excuse me, is when does the object hit the ground? Remember that the height of the ground is 0. What we do not know is the time, so we replace height with 0. Whoops, I should copy that correctly. Replace the height with 0. And to solve this equation, it is a quadratic, but because this quadratic does not have a b term, we don't have to use completing the square. You can use square root property if your quadratic does not have a b term. The b term would be 0t, right? So what I want to do is to get the perfect square by itself by first subtracting 210 from both sides. Then divide both sides by -16. Okay, so of course a negative divided by a negative is a positive. So this is the same thing as t squared is equal to positive 210 over 16. Now I do realize that that reduces. However, on MyOpenMath, it says that we can give our answers as decimal values accurate to 2 decimal places. So when I take the square root of both sides, rather than simplify this the way I would do in a usual problem, because it's a word problem and it requires rounding, I can use a decimal approximation. Now, I do not need to do plus or minus in this scenario. Usually the square root property will require you to add that plus or minus sign, but because time is never negative, instead of having plus or minus, I get to just have plus. Okay? So t is never negative, so I get to just have the plus, so now I can type this into the calculator. 210 divided by 16, then I'm going to take the square root of that number, and I get 3.62 seconds. Now make sure this is a reasonable answer. It should not take 50 seconds to drop an object 210 feet. An answer between 3 and 4 seconds is a reasonable time. Okay, so next let's look at the other questions on MyOpenMath. For my last 3 examples, I'm going to show you questions 8, 9, and 10 from MyOpenMath, which are actually really easy problems, but I can see how they can confuse you. So let's just see what they're asking. So in question 8, what's being asked is what number needs to be added to both sides to make this a true statement and to make sure that the left-hand side is a perfect square. So for question 8, this is simple. This is the step in MyOpenMath where you add b over 2 squared to both sides. So for all of these examples, we're going to add b over 2 squared. Okay, so b in this case is 10. 10 divided by 2 is 5. 5 squared is 25. And that's all you have to do. For question 9 and question 10, we are not actually keeping these expressions equal to the original expression. We are adding something, but it's asking what would I need to add in order to make each of these trinomials a perfect square. So questions 8, 9, and 10, all you need to do is figure out what b over 2 is and square it. In the case of 9, b over 2 is 16 over 2, and when you square 16 over 2, you get 8 squared, which is 64. In this case, 7 over 2 squared is going to be 49 over 4. So this is a case where b is an odd number. So the number you have here will end up being a fraction. Now, if you were to have a problem like this and you needed to factor it, remember that you always factor into x plus b over 2. So this would simply factor into x plus 7 over 2 squared. Question 10 doesn't actually require you to factor it. I just wanted to show you how to factor in the event that you do need to factor when you have a fraction here. Remember, just use the formula x plus b over 2, and then you already have your factorization. Okay, so then there are a couple more problems on MyOpenMath that follow, but they go through the steps of completing the square. So hopefully they'll be pretty straightforward, especially if you've already seen or comprehended the earlier part of the lecture. If you need to work through those examples again and again until you get them right, I would encourage you to do so. Try to be able to do the problems from the lecture correctly on your own before you try the homework. That will give you even greater success in the homework. I will see you in the next lecture.